Alright, on this example, notice how the trig expression is already isolated, but the only difference that I see in this problem is that for x. Okay? Before we would just have a single x. So what we're going to do is this for x, we're going to let a variable be that. Now you can choose any variable. I'm going to choose the letter u. You can choose theta, you can choose y, it's up to you. So I'm going to rewrite my problem as cosine of u is equal to 1 over 2. And now it just becomes a problem that we've done before, where again, this is your angle. Cosine is adjacent over hypotenuse, and those are labels for right triangle. So let's go ahead and come up with the possible locations for this angle. And notice how this time it's not x, it's u. So u is here, u prime for the reference angle over here, that looks like a W, and another angle over here. Create the right triangles associated with each of these terminal sides. Remember that, it always goes towards the horizontal axis. Let me zoom in on the drawing. And now let's start labeling our adjacent 1, hypotenuse 2 in all of these. So remember that if it happens to be negative, you worry about that based on your sketch. On the sketch, this one has to be negative, so automatically I can eliminate these two quadrants, and we'll make a note on here and indicate that cosine of u is actually negative 1 over 2, not positive the way they want this to be. Remember that the hypotenuse is always going to remain positive. So the terminal sides where the hypotenuse should be always positive, regardless of their location. Alright, so if I use Pythagorean theorem, this is going to be a square root of 3. This is going to be negative because of its location. And what's this angle then going to be? Yeah, 60, because across the square root of 3 should be a 60. This one should be 60. And let's go ahead and start from the positive x-axis towards this terminal side. That one's simply 60 degrees that I travel. Let me do the different color. So I would say u here is the 60 degrees. What about the other? I could say negative 60, but let's stick with the positive ones. Yeah, let's start, from the positive, go towards this terminal side. Remember, positive is counterclockwise. And so my answer here is going to be how many degrees? 300. Because again, if I were to complete that circle, it'd be 360, but I have to back up 60 to be in that terminal side. Alright, so now let's go ahead and write our answers. By the way, am I solving for u or am I solving for x? X. So right now I am at the stage where u is equal to 60 degrees plus 360 n. The only thing also is now I have to say u is equal to 300 degrees plus 360 n. Let's go ahead and convert these to radians. What's 60 in radian? Pi over 3 plus 2 pi n. And u is equal to 5 of these pi over 3's, or 60, 300 divided by 60 is 5, so 5 of the pi over 3's plus the 2 pi n. And like I had mentioned, we're not solving for u, we're solving for x, so we have to resubstitute back what we let u equal. So u is 4x, so 4x is equal to pi over 3 plus 2 pi n. 4x is equal to 5 pi over 3 plus 2 pi n. Let's divide by 4 to solve for x. What's pi over 3 divided by 4? Remember, divide by 4 is the same thing as multiplying by 1/4. So I have pi over 3 times 1/4 is going to be pi over 12. So plus, reduce the 2/4 is pi over 2n. And x is equal to, on this side, if I do the same thing, divide everything by 4, I get 5 pi over 12 plus pi over 2n. Alright, now that's in radian mode, of course, because of the conversion from degree to radians. The only issue is that in some cases, if you look at your assignments, for example, if you look at number 11, they may only want the answers from 0 to 360 or from 0 to 2 pi. If you stay in radian mode, it's going to be very difficult for you to determine the answers. So what I would suggest you do, I'm going to move over here, is once you have them in degree mode, not degree, is solve for them the same way that we did, but in degree, because usually in degree mode, it's a lot easier to work with than radian mode. So 4x is equal to this, and 4x is equal to this. And of course, the same process as the other one. Let's solve for x. We divide by 4, so x is equal to 15 degrees plus 90 degrees times x. X is equal to 300 divided by 4 is 75 plus 90. Now, why am I doing this if I already had the answers in radian? You could have also converted the radian one to degrees. Like, for example, this pi over 12 gives me the 15 degrees if I convert it. So I end up the same thing. But the reason I give this is, let's say, like I mentioned, I only want the answers from, let's say, from 0, we'll include the 0, to 2 pi. So for this, I would have to generate a list. So on this one right here, if I let n equal 0, I get 15 degrees. If I let n equal 1, 90 plus 15, I get 105 degrees. And just continue. N equals to 2, 180 plus 15 is 195. N equals to 3 is 270, because 90 times 3 plus 15 is 285. What happens if I let n equal to 4? What's 90 times 4? 360. And if I add 15, I go beyond that 2 pi. So I would have to stop at n equals to 3 and then just continue with this other list over here. N equals to 0, I get 75 degrees. N equals to 1, I get, what is that, 165. N equals to 2, 180 plus 75, 255. N equals to 3. 345, thank you. And the same thing as before, if I let n equals to 4, I go beyond the 360, so I would stop there. And again, it would be all these answers between 0 and 2 pi would actually work for x. If for whatever reason, like if you look at number 11 on your handout, you may have to just convert these back to radians. Now, why did I do this if I already had the answer is over here in radian mode, because working with fractions is a lot more difficult. Like if I ask you, okay, from here, give me all the answers between 0 and 2 pi, well, you're going to have to give me a list. You're going to say, well, n equals 0, you get pi over 12. N equals 1, you know, if you don't have a calculator, I mean, you can do it. You could say pi over 12 plus pi over 2 times 1, but you're going to have to find the LCD, combine it. It's a little bit more work than if you just use the degree, uh, the answers in degrees, and then just go back and convert them. Okay. So just be careful with those. Like I said, while this is a final answer, this is an answer also if they ask from 0 to 360. All right, any questions on this one?